Somewhere near you right now, the internet's awake. Maybe it's the phone charging on your nightstand. Maybe it's a laptop, half closed, still humming. Maybe it's just a router blinking quietly in another room, doing its small, tireless job while you do nothing at all. And there's the strange part. It never stops for you. While you're lying here, getting comfortable, letting your eyes go heavy. Somewhere on the other side of the planet, a message is arriving. A photo is uploading. A server is answering a question it's been asked 10,000 times tonight. Someone is watching a video at 2 a.m. and telling themselves it's the last one. Someone else is wide awake, arguing with a total stranger about something that will not matter by breakfast. A satellite passes overhead. A cable under the ocean carries a piece of a conversation somewhere. Someone is doing exactly what you're doing right now. Lying in the dark, letting a voice talk them to sleep. Powered by the very thing the story's about. We like to talk about the internet as if it's one object. A place, a machine you can point to. It isn't. It never was. The internet is really just an enormous, sprawling agreement. Millions of separate networks run by different companies and countries and universities, all agreeing to speak the same basic language so their machines can talk to each other. That's it. That's the whole secret. Not one machine. A conversation between machines, repeated an unimaginable number of times a second. And like most good stories, it didn't arrive all at once. It crawled before it walked. It started as a strange little experiment involving 4 computers and a handful of researchers who had no idea what they were building. It grew into a way for scientists to share their work, then a way for strangers to talk, then a place to build things, then a marketplace, then entertainment, then somewhere along the way, it became the place where a huge portion of human life quietly relocated. So tonight, we're going all the way back, before the apps, before the feeds, before Google was a verb, before there were websites at all, or a web to speak of, or even a reliable way to get one computer to say hello to another. We're going to follow this thing from its very first half-finished word to the version of it sitting in your hand right now. Picture a computer in 1965. It's not sitting on a desk. It's the size of a room. It hums like a refrigerator the size of a house. And it belongs to one university, or one government lab, or one branch of the military. And it does not talk to anyone else's computer. It can't. There's no reason for it to. It was never built to. Computers in those early decades were islands. Expensive islands. If you wanted to use one, you often had to be standing in the same building it was in, waiting your turn. And that was the problem someone eventually had to solve. Computers were becoming remarkably useful, but they were also absurdly expensive, and the university 3 states away might have one sitting mostly idle. Wouldn't it be useful if a researcher elsewhere could reach it, use its processing power, share what it knew? That question, deceptively simple, is really where this whole story begins. It also happened to be in the middle of the Cold War, and the US government was pouring money into anything that looked like it might matter strategically. In 1958, the Department of Defense created a research wing called the Advanced Research Projects Agency, ARPA, whose entire job was to fund the kind of ambitious, slightly speculative research that might pay off in 20 years, if it paid off at all. Connecting computers was exactly that kind of bet. But there was a real engineering problem standing in the way, and it had to do with how telephone networks worked. When you called someone in 1965, The phone system built a single dedicated line between your phone and theirs. That line stayed open for the whole call, whether you were talking or not. For a conversation between two people, that's fine. Mostly, you're both actually talking. Computers don't work like that. A computer might send a short burst of data, then go quiet for a while, then send another burst. Reserving an entire dedicated line for that kind of stop and start chatter is enormously wasteful. Like renting an entire highway to yourself just to occasionally drive a bicycle down it. So a handful of researchers working mostly independently arrived at a different idea. What if you broke a message into small pieces, packets, and let each piece find its own way through a shared network to be reassembled at the other end? Think of it less like a single phone line and more like a huge web of roads. Your message gets chopped into small packages. Each package finds a path across the network. If one road is jammed or broken, a package can be rerouted. When they all arrive, the destination puts them back together in order, and nobody on the other end even notices it happened in pieces. It's called packet switching, and it is, without much exaggeration, the single idea the entire internet is built on. Now all that was left to do was actually build the thing. By the late 1960s, APRA was ready to test packet switching for real, and they needed hardware to make it happen. Something that could sit between a university's mainframe computer and the experimental network, translating between the two. That piece of hardware was called an interface message processor, or IMP, and a small engineering firm called BBN got the contract to build it. In 1969, the very first nodes of this experimental network went live. 4 of them. Just 4. UCLA, the Stanford Research Institute, UC Santa Barbara, and the University of Utah. Take a second to sit with that. The system that would eventually connect billions of people in nearly every country on Earth started with 4 university buildings that could, technically, barely talk to each other. And the very first attempt to actually use it has become one of the great origin stories in computing, mostly because of how spectacularly it fumbled the moment. On an October evening in 1969, a UCLA student named Charlie Klein sat down to log into the SRI computer remotely. The word he needed to type was simple: log in. He typed L. It transmitted. Good. He typed O. That went through too. Then the whole system crashed. So the first message ever sent across that would become the internet wasn't a word. It wasn't even close to a word. It was 2 letters, cut off mid-thought. L-O. Low. Which, if you enjoy a little cosmic irony, is a strangely perfect way for the story to begin. A machine built to connect the world, opening its mouth to say something profound, and instead just trailing off. They fixed the crash. They tried again, and it worked the second time. The network kept growing after that. More universities, more computers, more researchers building the actual rules of how machines on this thing should talk to one another. And almost immediately, something happened that nobody had really planned for. In 1971, an engineer named Ray Tomlinson, working on ARPANET, mostly trying to solve a fairly unglamorous technical problem, built a way to send a message from one computer to a specific person on a different computer. To make that work, he needed a symbol to separate the person's name from the machine they lived on. He looked down at his keyboard and picked the @ sign, mostly because it wasn't being used for anything else. Email was born, more or less by accident, as a side effect of somebody trying to solve a routing problem. And here's the pattern worth remembering, because it's going to repeat again and again throughout this story. ARPANET wasn't built so people could send each other messages. It was built to share expensive computing power between research institutions. But the moment people had a way to reach each other, they used it to talk, not to compute. To talk. Every single time this technology gets more capable, people find a way to turn it into a conversation. That's not a side effect of the internet's history. That basically is the internet's history. But ARPANET, for all its cleverness, was still just one network. And the next problem was bigger. What happens when you want completely different networks, built by different people with different rules, to talk to each other? Imagine three separate networks. One uses one set of rules for moving data. Another uses a completely different set. A third does its own thing entirely. You can connect the computers within each network just fine. But how do you connect the networks to each other when they don't even agree on the basics? This exact problem that occupied two researchers, Vint Cerf and Bob Kahn, through most of the 1970s, and their answer turned out to be one of the most quietly important decisions in the whole history of computing. They didn't try to force every network onto one single, unified system. That would have meant asking everyone to throw out what they'd already built and start over, which is, generally, a great way to get nobody to cooperate with you. Instead, they designed something smaller and stranger, a shared language that different networks could speak on top of what they were already doing internally. Each network could stay exactly as weird and specific as it wanted to be on the inside. It just needed to agree on how to hand information off at the edges. That became TCP/IP, Transmission Control Protocol, and Internet Protocol. You don't need to remember what the letters stand for. What matters is the idea underneath them. The internet was never one giant uniform network. It was an agreement between many different, stubbornly independent networks, all willing to speak one common language at the border, which is still exactly how it works today, from your phone to your provider to a data center on another continent. On January 1st, 1983, ARPANET formally switched over to TCP/IP, retiring the older system it had been using. Researchers still sometimes call this Flag Day, and it's often treated as one of the true birthdays of the modern internet. Not because the internet suddenly appeared that day, but because this was the moment the growing patchwork of networks finally had one shared foundation to stand on. There was still a very human problem left. The network needed names. Computers were happy identifying each other with strings of numbers, but people are not computers, and nobody wants to memorize a phone book of numeric addresses just to check their email. So engineers built the domain name system, essentially the internet's phone book, letting people type a name instead of a number, while the machinery quietly translated one into the other behind the scenes. By the mid-1980s, then, you had a real, functioning internet. Universities were connected. Email worked. Files could be transferred. Researchers across the country, and soon across the world, could reach each other's machines. But if you'd sat down at a computer in 1987 and asked to browse the internet, nobody would have known what you meant. There was no web yet, no pages, no links, no scrolling. The roads existed. Nobody had built anything to drive on them. That was about to change in a physics lab in Switzerland, because one researcher was tired of not being able to find his own documents. CERN, the European Particle Physics Laboratory, was and is an unusual place. Thousands of scientists cycling in and out from universities all over the planet, all trying to collaborate on the same enormously complicated experiments, all using different computers, different software, different filing systems. If you wanted to find a colleague's research notes, there was a real chance you'd need to know exactly which machine they were stored on, exactly what format they were in, and exactly whom to email to ask for access. A researcher there named Tim Berners-Lee found this constant friction genuinely maddening. In 1989, he wrote up a proposal. His supervisor famously scrawled, vague but exciting, across the top of it, describing a system based on an old idea called hypertext, documents that could contain links to other documents. So you could simply click your way from one piece of information to the next, regardless of what machine it happened to live on. It sounds almost too obvious now to be an invention. That's usually the sign of a genuinely good idea. In hindsight, it looked inevitable. Berners-Lee didn't just describe the idea. He built the entire toolkit needed to make it real, essentially by himself, in a fairly short window of time. HTML, the language for writing linked documents. HTTP, the protocol for requesting and delivering them. And the URL, the address system for finding them. He also wrote the first web browser and the first web server, running on a Next computer sitting on his desk at CERN, a machine so central to the project that famously it had a handwritten note taped to it begging people not to turn it off, because it was the entire World Wide Web at that point. By the end of 1990, the machine was serving the very first website ever published. Its address was info.cern.ch, and in a small, satisfying loop, its subject was the web itself, an explanation of what this new thing was, and instructions for how anyone else could build a page of their own. Here's the decision that made everything after this possible. In 1993, CERN released the underlying web technology into the public domain. No licensing fee, no permission required. Anyone, anywhere, could build a website or a browser without paying CERN a cent. That single choice is arguably why the web became the web, instead of one interesting but obscure academic project among hundreds. It meant a student in one country and a company in another could both start building on it the same afternoon, with nobody's permission needed and nobody standing at the gate. The internet, remember, had already existed for 2 decades at this point. What had been missing wasn't the plumbing, it was a front door. The web didn't invent the internet, it gave the internet a face. And once people could finally see it, they started filling it with absolutely everything. Let's be honest about something. The early public internet was ugly, gloriously, unapologetically ugly. There were no clean feeds, no algorithms deciding what you'd like, no infinite scroll nudging you toward just one more. Instead, bulletin board systems, mailing lists, news groups, chat rooms, and the earliest personal websites all reached through a technology most people now only remember by its sound: the modem. A bulletin board system, or BBS, was essentially someone's personal online clubhouse. run out of their bedroom on their own computer and phone line. You'd dial in, the two machines would negotiate a connection, and suddenly you were inside somebody else's little corner of the internet, reading messages, downloading files, talking to whoever else happened to be logged in. Some were about games, some about music or politics, or hobbies nobody else in your town cared about. Each one had its own personality, because each one was run by one person's taste. Usenet scaled that up into thousands of topic-based discussion groups. IRC got you closer to a live conversation. You joined the channel, and whoever was there was who you talked to. None of it was built around advertising. Nobody was optimizing these spaces to keep you scrolling. They were just places. Small, strange, specific, usually kept alive by people doing it for free. And then there were the sound itself. That shrieking, chirping handshake a modem made over an ordinary phone line, meaning that in a few seconds you'd be somewhere else. The connection was painfully slow. Images loaded one strip at a time, like a photograph developing in a dark room. Pick up the phone number in another room and the whole thing could drop. But there was something close to magic in it. Alone in your bedroom, through a sound like a robot clearing its throat, you were suddenly connected to strangers who you'd otherwise never have had any reason to meet. That's the moment the internet stopped being a research tool and quickly became a social one. As the 1990s went on, the number of websites exploded, and people needed some way to find their way around all of it. Yahoo started as, essentially, a hand-curated directory of websites, a phone book for the internet, organized by category, maintained by actual people clicking around and deciding where things belonged. Alta Vista became one of the major search engines competing for the same job. And then something wonderful happened. Ordinary people started building their own websites, just because they could. This was the era of GeoCities, free, simple web hosting that let anyone with zero design experience and zero budget claim a little plot of internet real estate and decorate it however they wanted. And decorate they did. Neon backgrounds, animated gifs of flames and dancing babies, text that blinked, visitor counters that ticked up any time a person entered the website, just like a badge of honor. Under construction signs on pages that would never ever be finished. Guest books where strangers left messages. Photo galleries. Long, sincere lists of somebody's favorite bands, favorite movies, favorite anything. It was chaotic. It was often genuinely bad by any design standard. And it was completely, refreshingly personal. Compare that to today, where you already know, before you even click, roughly what a major website is going to look like. A navigation bar up top, a search box, a clean grid of cards, a login button in the corner, ads carefully slotted into the layout, everything following the same handful of design conventions you've seen 1,000 times before. The early web had none of that shared visual language yet, because nobody had settled on one. It wasn't a shopping mall. It was closer to an enormous, sprawling neighborhood of badly decorated bedrooms, each one built by someone who just wanted a place on the internet that was theirs. That wouldn't last, because somewhere around this time, businesses started looking at all this traffic, all this attention, all these eyeballs, and realized there might be an enormous amount of money sitting right there, waiting to be picked up. By the late 1990s, the internet has stopped looking like an experiment and started looking like a gold rush. Companies were racing to launch websites. Investors were pouring money into anything with .com attached to its name. There was a genuine, widespread belief sweeping through business and finance that every company eventually would become an internet company, and that getting there first was worth almost any price. Some of the bets paid off spectacularly. Amazon started as an online bookstore and quietly built the infrastructure to become something much larger. eBay built an entire marketplace out of the simple idea of letting strangers buy and sell directly from each other. And in 1998, a small search engine called Google launched, built around a genuinely clever idea for ranking results, and it would go on to become one of the defining companies of the entire internet era. But the enthusiasm ran well ahead of the reality. Investors began funding companies that had barely any revenue, sometimes barely any actual product, purely because they had an internet business model and a compelling pitch. The assumption, largely unquestioned at the time, was that growth alone would eventually turn into profit. For a lot of these companies, it never did. The bubble that had been inflating through the late 90s began collapsing around 2000. Companies that had been valued in the billions vanished within months. Fortunes evaporated. It was, for a lot of people who lived through it, a genuinely painful few years. But, and this matters, the internet itself didn't go anywhere. The infrastructure stayed exactly where it was. The companies with real, useful products mostly survived. And out of the wreckage, a new wave of internet businesses began to grow, shaped by a lesson the first wave had learned the hard way. The next shift wasn't really about buying and selling. It was about who got to publish. Because up to this point, the internet had mostly still been something you read, which was about to change. Sometime in the early 2000s, people started using a new phrase to describe where the internet was heading. Web 2.0. It wasn't a new piece of technology so much as a new relationship between people and the web. One where you didn't just read a website, you helped build it. Blogs let ordinary people publish their own writing to a global audience with zero technical skills required. Wikipedia turned the old idea of an encyclopedia inside out, letting anyone edit an article. And somehow, despite every reason to expect chaos, it mostly worked. Online communities grew around shared interests. People uploaded their own photos, commented on each other's posts, built profiles that were, in a small way, public versions of themselves. And then video arrived, and everything sped up. YouTube launched in 2005. The very first video ever uploaded to the site was posted by one of its co-founders, Jawed Karim. 18 unmarkable seconds of him standing in front of elephants at the San Diego Zoo, talking about essentially nothing. That's it. That's how the platform that would eventually host billions of hours of video began. Before YouTube, getting a video in front of a large audience meant getting onto television, or physically distributing a disc, or somehow building your own hosting infrastructure. YouTube collapsed all of that down to record something, click upload. Google acquired the company the following year. in 2006. Around that same stretch of time, Facebook was expanding rapidly beyond its own original college campus roots, and Twitter launched in 2006, condensing publishing down to something you could do in a single sentence from your phone. Suddenly, publishing to the entire world wasn't something you needed a newspaper, a TV network, or a record label to do. Anyone with an internet connection could do it. Your friends could do it. Strangers could do it. Companies, celebrities, hobbyists, teenagers in their bedrooms, everyone, all at once, became a publisher. And that created a genuinely new problem, one the internet hadn't really faced before. If everyone's publishing constantly, who decides what you actually see? Increasingly, the answer wouldn't be you. The next big shift didn't happen on a desk. It happened in a pocket. In January 2007, Apple introduced the iPhone, a phone, an iPod, and an internet device, folded into one piece of glass with no physical keyboard, which at the time was genuinely strange and risky. Phones could already technically get online before this. That wasn't the breakthrough. The breakthrough was that the internet stopped being something you sat down to visit and became something that simply lived in your pocket, all day, everywhere you went. In 2008, Apple opened the App Store, and the appetite for it was immediate. Over 10 million downloads in its first very week, and past 100 million by that September. An entire new economy sprang up almost overnight, built around small pieces of software you carried with you. Once that happened, the old boundary between online and offline started dissolving. You could check email on a sidewalk, look something up mid-conversation at dinner, take a photo and have it published to the world before you'd ever sat down. Pull up a map on a street corner in a city you'd never visited. Watch a video on a bus. Talk to someone on the other side of the planet while standing in line for coffee. Being connected stopped being a decision you made by sitting at a desk. It became the default state of things, something you were rather than something you did. And once nearly everyone was online, all the time, carrying a device that quietly logged everything they touched, companies suddenly had an extraordinary opportunity in front of them. They could watch what you clicked, what you lingered on, who you followed, and how long you stayed up before you left. And with enough of that information, they could start making a very confident guess about what to show you next. The internet was about to start to think for you. For most of the internet's early life, you had to go looking for things. You typed a search. You clicked a link. You typed an address you already knew by heart. You walked, in a sense, into the room you wanted to be in. The modern internet mostly doesn't wait for you to ask. Open an app and there's already a feed sitting there, fully loaded. You don't request the next video, it simply arrives, because something has already made a fairly confident guess about what will keep you there a bit longer. Recommendation systems themselves weren't new. What changed was the sheer volume of behavior these platforms could observe. Did you watch to the end? Pause, scroll straight past, like it, share it, ignore it, and how precisely they could act on it. Facebook leaned hard into algorithmically ranked feeds. YouTube built one of the most sophisticated recommendation engines anywhere on the internet. TikTok pushed it further still, learning a brand new user's taste within minutes. The upside is real. Open an app and you're instantly looking at something genuinely interesting, with almost no effort. But the internet stopped behaving like a library and started behaving more like a machine to hold your attention as long as possible. Because attention, it turns out, is one of the most valuable things in the world. And the better a platform gets at predicting what keeps you scrolling, the more it's worth. Which brings us, more or less, to the internet most of us actually live inside today. Fast, deeply personalized, essentially endless, and, if we're honest, not always easy to put down. Somewhere along the way, the internet quietly stopped being a category of technology and became something closer to infrastructure, like electricity or plumbing, something underneath everything else, rarely noticed until it fails. We stream entertainment through it, we work through it, we study, shop, bank, and store our memories through it. And increasingly, a huge amount of the actual computing involved doesn't happen on the device in your hand at all. It happens somewhere else, entirely, in a building you will never see. That's the idea behind the cloud, a name that makes it sound far more mysterious than it actually is. When you upload a photo, it isn't floating anywhere. It's sitting on a physical hard drive, inside a physical server, inside an actual building, a data center, somewhere on the planet, owned by a company, renting you a small sliver of its storage. That's the entire trick behind losing your phone and signing into a brand new one, only to find every photo, message, and document already waiting for you. The photos were never really on your old phone to begin with. They were just being shown to you. Streaming reshaped entertainment around the same idea. Instead of owning a physical copy of a film or an album, you simply reach out to a server that holds it for you. Games increasingly work the same way. So does software you use for work. An entirely new category of media personality emerged alongside all of this. Some with just a camera and an internet connection, capable of reaching an audience the size of a television network, without ever needing a television network's permission. But there's a cost sitting quietly underneath all of this convenience. The modern internet has also become an extraordinarily thorough system for observing you, and a substantial portion of its economy is built on collecting, studying, and acting on that every trail of behavior. The internet had become astonishingly powerful. It had also become astonishingly complicated, and not entirely on our own terms. And then it got one more new layer. Artificial intelligence isn't new. Researchers have been working on it for decades, but the recent wave of genuinely capable generative AI systems changed something fundamental about the relationship between people and computers. For the internet's entire history up to this point, you mostly used it to find things other humans had already made. A search engine pointed you toward a page somebody had written. A feed showed you a video somebody had filmed. The internet was, at its core, an enormous archive of human output, organized and served back to you. Generative AI changes that arrangement. Instead of only searching for something that already exists, you can now simply ask a machine to make something new. A paragraph, an image, a piece of code, a translation, whatever you want or need. The line between finding information and generating information has started to blur in a way it never really has before. And the adoption curve has been remarkably steep. Stanford's 2026 AI Index reports that generative AI reached an estimated 53% of the population within about 3 years of its emergence, faster than the personal computer or the internet reached comparable adoption levels, and that organizational AI adoption reached 88% among surveyed organizations. which means we appear to be entering yet another distinct chapter of this same long story. The first internet connected computers to each other. The web connected information. Social media connected people to each other. Algorithmic feeds connected people to personalized streams of that information. And now AI is starting to connect people to systems that can actively produce and reshape information on request, rather than simply retrieving it. Instead of typing a search and reading through 10 links yourself, you might just ask and let something else do the reading. Instead of editing a video by hand, you might describe what you want and watch it appear. Instead of drafting an email from scratch, you might ask a system to draft it for you and simply adjust the tone. The interface itself is quietly shifting. For 50 years, learning to use a computer meant learning to speak its language. Menus, commands, syntax. Increasingly, it's starting to work the other way around. Nobody, genuinely nobody, knows exactly where that leads next, which is, in its own way, a very fitting place for the story to be standing right now. Now, here's the thing that strikes me the most. Looking back across this whole story, almost none of it was planned the way it actually turned out. The engineers who built ARPANET weren't trying to invent Instagram. Tim Berners-Lee, sitting at his desk at CERN, wasn't imagining YouTube. The people who built the earliest social networks almost certainly weren't picturing a single algorithm quietly shaping what billions of people would see. And the people building today's AI systems probably don't know exactly what the internet is going to look like in 10 years. That's the real pattern running underneath everything we've talked about tonight. A tool gets built for one narrow purpose. People find another use for it entirely. And then, gradually, millions of people build something together that nobody involved at the start ever quite imagined. The internet was never really one invention. It's layer after layer, stacked over more than half a century. Protocols, then networks, then browsers, then platforms, then phones, then algorithms, and now whatever comes next. Each one making the whole structure a little harder to separate from ordinary life. When you wake up tomorrow, all of it will already be waiting for you. Messages arrived, something recommended, photos safely stored somewhere far away. And underneath every bit of it will be the exact same idea that started this whole story. One computer sending information to another, and arriving without you ever noticing the trip. In 1969, the entire system was 4 computers and a crashed connection halfway through the word login. Tonight, it's billions of devices, all speaking a language a small group of researchers invented mostly by accident. Most of the time, we don't think about any of it. We don't think about the cables running along the ocean floor, or the buildings full of servers, or the protocols quietly routing everything behind the scenes. We just open an app and it works. Till every so often, it doesn't. And for a few minutes, we're reminded that none of this was ever magic. It's cables and machines and radio signals and rules that people wrote down, and underneath absolutely all of it, people deciding over and over again across 50 years that they wanted a way to reach each other. And right now, while you're laying here, that enormous system is still quietly running. Another packet moving, another server answering, another message on its way somewhere. The internet doesn't really sleep, but you can.